Start. Good afternoon, everybody. My name is Malla Reddy, JL in Chemistry, Choutuppal. Second year Chemistry. Lesson is Group 17 Elements. Group 17 Elements. Elements names: fluorine, chlorine, bromine, iodine, astatine. Elements: fluorine, chlorine, bromine, iodine, astatine. Fluorine atomic number is 9. Fluorine atomic number is 9. Electron configuration: helium 2s2 2p5. Helium is 2 electrons. Totally 9 electrons. Once again, fluorine electron configuration: helium 2s2 2p5. Next, chlorine 17, atomic number 17, neon 3s2 3p5. Chlorine atomic number 17, electron configuration is neon 3s2 3p5. Next one, bromine atomic number is 35, argon 3d10 4s2 4p5. Bromine atomic number is 35, 3d10 4s2 4p5. Next one, iodine atomic number is 53, krypton 4d10 5s2 5p5. Iodine atomic number is 53, electron configuration krypton 4d10 5s2 5p5. Last one, astatine atomic number is 85, electron configuration xenon 4f14 5d10 6s2 6p5. Now fluorine outermost configuration, 2s2 2p5. Chlorine outermost configuration 3s2 3p5. Bromine outermost configuration 4s2 4p5. For last orbit is fourth orbit 4s2 4p5. Bromine outermost configuration is 4s2 4p5. Next one, iodine outermost configuration 5s2 5p5. 5s2 5p5. Last one, astatine outermost configuration 6s2 6p5. 6s2 6p5. Now, what is the general configuration of 70th group elements? Means 2s2 2p5, 3s2 3p5, 4s2 4p5, 5s2 5p5, 6s2 6p5. General configuration is ns2 np5. General configuration is ns2 np5. ns2 np5. Total valence electrons is 7. Total valence electrons is 7, equal to the group number generally. Total valence electron 5 plus 2 7 equal to the group number. Next one, general oxidation number of 17th group elements. -1. Gain of 1 electron reach the octet configuration, noble gas configuration. So gain of 1 electron. So general oxidation number is -1. Generally, 70th group elements right side of the periodic table. Right side of the periodic table, left of the zero group elements. Left of the zero group elements. Next one, another one, 17th group elements is also called halogens. 17th group elements are also called halogens. Halogens is Greek word. Halogens is a Greek word. Because These are salt producers. Once again, 17th group elements is also called halogens. Halogens. Halo means, this is Greek word. Halo means salt. Gens means producers, salt producers. So these elements are also called salt producers. Salt producers. Next one, 17th group elements, P block elements. 17th group elements are P block elements. The differentiating electron enter into the p orbital. P orbital is called P block elements. So 17th group elements are P block elements because the differentiating electron enter into the p orbital. So it's called P block elements. P block elements. Next one, physical state. Physical state of these elements. Fluorine and chlorine are gases. Fluorine and chlorine are gases. Bromine is liquid. Bromine is liquid. Iodine and astatine are solids. Once again, physical state of these group elements, fluorine and chlorine are gases state. Bromine is liquid state. Iodine and astatine are solids. Astatine is a radioactive element. Astatine is a radioactive element. Astatine is okay. Astatine is a radioactive element. Next one, occurrence. Occurrence. First element is fluorine. Fluorine occurrence is fluorospar, CaF2, fluoropatite, 3Ca3PO4, CaF2. Once again, fluorine occurrence, fluorospar, CaF2. Second one, fluoropatite, 3Ca3PO4 taken to CaF2. Another one also there, cryolite. Third one is cryolite, Na3Al F6. Cryolite, Na3Al F6. Fluorine occurrence. Next one, chlorine and bromine and iodine. Seawater, generally seawater containing chlorine, bromine, iodine of sodium, potassium, magnesium and calcium. Once again, seawater contain chlorine, bromine, iodine of sodium, potassium, magnesium and calcium. Now chlorine occurrence, seawater, NaCl. Next, carnallite, very important source. Carnallite, KCl, MgCl2, 6H2O. Carnallite, KCl, MgCl2, 6H2O. Another one, third one also there, horn silver, AgCl. Horn silver, AgCl. Fourth one also there, Sylvine, KCl. Once again, chlorine occurrence, seawater, NaCl. Second one, carnallite, very important, KCl, MgCl2, 6H2O. Third one, horn silver, AgCl. Fourth one, Sylvine, KCl. Next, fluorine is completed. Chlorine is completed. Next one, bromine. Bromine also against MgBr2, magnesium bromide. MgBr2, magnesium bromide. And also iodine. Iodine also sodium iodate. NaIO3. So astatine is radioactive element. Okay. Once again, occurrence fluorine, fluorospar, CaF2, fluoropotide, 3Ca3 PO4 taken to CaF2. Next cryolite, Na3AlF6. Next chlorine, present seawater, NaCl, cornolite, horn silver, AgCl, Sylvine, KCl. Bromine also sources magnesium bromide, MgBr2. Iodine also sodium iodate, NaIO3. Now discuss some general properties: atomic size, ionization potential, electropositivity, electronegativity, electron gain enthalpy, metallic nature. The general properties discussed. Now, first one discuss atomic size. Atomic size or atomic radius. Atomic size or atomic radius. Atomic radius. Seventh group elements have lowest atomic size in their respective periods. Seventh group elements have lowest values of atomic size in their respective periods, because left to right atomic size decreases. Left to right in period, left to right atomic size decreases. And also maximum effective nuclear charge increases. Maximum effective nuclear charge increases. So 17th group elements have lowest atomic values. Lowest atomic values. Now top to bottom. Our topic is group. Top to bottom. Top to bottom, group in top to bottom or down the group. Atomic size increases. Top to bottom atomic size increases. Fluorine to iodine atomic size increases because the differentiate electron enter into the new shell. Atomic size from top to bottom increases because the new electron enter into the new shell. So F fluorine to iodine atomic size increases. Next one, IE, ionization enthalpy. Ionization enthalpy or ionization potential. Ionization potential. These group of elements, ionization potential is very high in their respective periods. Now, top to bottom, ionization enthalpy, and from F22 and fluorine to iodine, ionization enthalpy decreases. In group from F2 to iodine, ionization enthalpy decreases. Ionization enthalpy decreases. What is the meaning of definition of ionization enthalpy or ionization potential? The ionization enthalpy definition: the amount of energy is required to remove an electron in outermost shell in gas atom. Once again, the amount of energy is required to remove an electron in outermost shell in gaseous atom. So totally the ionization enthalpy top to bottom decreases. Next one, electronegativity. 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 These left to right electronegativity increases from top to bottom in group. Our topic is group. Okay, group electronegativity from top to bottom decreases. Electronegativity from fluorine to iodine, electronegativity decreases. In total periodic table, F is the most electronegative value. The value is 4.0. in Fouling scale method. F is most electronegative value 4.0. The electronegativity left to right increases, top to bottom decreases. Top to bottom means group, left to right means period. Next one, electron gain enthalpy. Electron gain enthalpy. Electron gain enthalpy. Electron gain enthalpy. Another name also electron affinity. Electron affinity. Top to bottom, electron gain enthalpy, top to bottom in group, top to bottom electron gain enthalpy decreases. Decreases. Electron gain enthalpy in group from top to bottom decreases. Down the group decreases. But Cl is the most electron gain enthalpy compared to F, because F is small size and strong electronic repulsions present in fluorine atom. Once again, electron gain enthalpy fluorine is less than chlorine because F is small size and strong electronic repulsions are present in fluorine element. Fluorine element. Now the question, now the explanation, every group second element is more electron gain enthalpy compared to first element. Once again, fluorine, chlorine. Chlorine is second element in the group. Chlorine is the second element of the 17th group. Every group, second element is more electron gain enthalpy compared to first element. What is the reason means? So F is a small size and strong electron repulsions. F the Cl value is electron gain enthalpy value is 349 kilojoules per mole. Chlorine electron gain enthalpy value is 349 kilojoules per mole. F electronegative value is 4.0. Clarity చూసుకోండి. F electronegative value is 4. The highest high electronegativity. Cl is electron gain enthalpy value is 349 kilojoules per mole. Now halogens have the smallest size in their respective periods. Halogens have the smallest size in their respective periods. Smallest size in their respective periods. Because left to right atomic size decreases because the differentiate electron enter into the same cell. Once again, halogens have the smallest size in their respective periods. In period left to right, atomic size decreases. Atomic size decreases, the differentiate electron, new electron enter to the same cell. So increase the effective nuclear charge. Next one, color property. Color property. Fluorine, chlorine, bromine, iodine. Fluorine is a yellow color. Fluorine is a yellow color. Chlorine is a greenish yellow. Fluorine is yellow color. Chlorine is greenish yellow. Bromine is reddish brown. Iodine is a violet color. Once again, fluorine is yellow color. Chlorine, Cl, greenish yellow, bromine reddish brown, iodine is a violet color. Some explain how is it to exhibit the color properties. Generally, F is small size. F is a small size. Observe the high frequency of violet color. Once again, F is small size. Observe the high frequency of violet color and liberate the low frequency of yellow color. Yellow color. F is small size. Observe the high frequency of visible region. High frequency of violet color and liberate the low frequency of yellow color. Another one explanation, iodine. Iodine is a last element in the 17th group. The atomic size is more. Iodine atomic size is more in the group. Iodine is big size. Observe the low frequency of yellow color and liberate the high frequency of violet color. Now the question, explain the color properties of 17th group elements. Explain the color 2 marks. Explain the color properties of 17th group elements means generally F is greenish yellow, chlorine is F is yellow color, Cl is greenish yellow, bromine is reddish brown, iodine is violet color. So this is the explanation of color property. The next one, hydrates. Hydrates. 17th group elements, hydrates. Hydrates general formula is HX. X means halogens. X means halogens. Fluorine, chlorine, bromine, iodine. X means halogen. Fluorine, chlorine, bromine, iodine. So general formula is HX. Now HF, HCl, HBr, HI. Hydrofluoride, hydrochloric acid, hydrogen bromide, hydrogen iodide. Generally, stability, properties of hydrates, 17th group hydrates. Stability, top to bottom decreases. Stability, top to bottom decreases. HF greater than HCl greater than HBr greater than HI. HF greater than HCl greater than HBr greater than HI. Now the question, which is more stable, HF or HI? HF is more stability. More stability. Next one, bond dissociation enthalpy. Bond dissociation enthalpy. This address decreases. Down the group decreases. Stability, bond dissociation enthalpy directly proportional. Same stability order. This is also same stability order. Bond dissociation enthalpy, HF greater than HCl greater than HBr greater than HI. Bond dissociation enthalpy, stability, both are same order. Both are same order. Next one, acidity. Acidity. This hydrates increases. HF less than HCl less than HBr less than HI. Acidity is opposite. HF less than HCl less than HBr. less than Hi. These are general properties of hydrides. Stability order, bond dissociation enthalpy are same. SDT order opposite. So some preparation of hydrides, preparation of hydrides. First discuss చేయాలి next వస్తుంది. Preparation of hydrides. H2 plus X2. H2 plus X2 gives rise to HX. HX means hydrogen halide. Hydrogen halide. Example. H2. X means halogens. Fluorine, chlorine, bromine, iodine. H2 plus F2 gives rise to HF. H2 plus F2 gives rise to HF in the presence of dark. Because Ft is highly reactive compared to other elements in the same group. Ft is highly reactive. F2 plus H2 plus F2 gives rise to HF in the presence of dark. To formation of HF, Ft is highly reactive compared to other elements in the same group. Next one, H2 plus Cl2, 2HCl. H2 plus Cl2, 2HCl. Example, general examples. H2 plus Cl2 gives rise to HCl. In the presence of sunlight, Ft is dark place lo react avutundi, but Cl2 is in the presence of sunlight. Less reactive compared to F2. Ft is more reactive with hydrogen, chlorine less reactive with hydrogen. This is dark, another one is sunlight. Third one, bromine. H2 plus Br2. H2 plus Br2 gives rise. H2 plus Br2 gives rise to HBr. H2 plus Br2 gives rise to HBr. At 593 Kelvin and sunlight is present. Temperature also required. Less reactive. That means less reactive compared to Cl2. H2 reactive with Br2 to form hydrogen bromide in the presence of sunlight and also maintain the temperature at 593 Kelvin. 593 Kelvin. Last one. Okay. Last one. H2 plus I2. H2 plus I2. H2 plus I2 gives rise to Hi. Hydrogen react with iodine to form hydrogen iodide. In the presence of platinum catalyst. Temperature at 713 Kelvin. 713 Kelvin. This reaction is a reversible change reaction. Very, very important. Hydrogen, H2 plus I2. H2 react with I2 in the presence of platinum catalyst. The temperature is 713 Kelvin to form hydrogen iodide. This reaction is a reversible change reaction. Very, very important. What is important? Reversible. Now the statement conclusion, which is a high reactive? F2, Cl2, Br2, I2. F2 is a dark place, also reactive. Cl2, sunlight. Br2, sunlight and some temperature. I2, with catalyst and temperature. So, which is more reactivity? F2 greater than, Cl2 greater than, Br2 greater than I2. This is very, very important. Order of the reactivity of halogens. F2 greater than, Cl2 greater than, Br2 greater than I2. Because F2 high reactive because low bond dissociation enthalpy. What is very important? Why FT is highly reactive? Why FT is highly reactive means F single bond F, low bond dissociation enthalpy. Low bond dissociation enthalpy is very highly reactive. Very what important? And atomic size also small. Low bond dissociation enthalpy and atomic size also small. Now the another point. All the halogens are highly reactive. All the halogens are highly reactive. Next point. The reactivity of halogens from top to bottom decreases. The reactivity of halogens from top to bottom decreases. Now, F2 is super halogen. This is very important word. F2 is super halogen because highly reactive compared to other elements within the group. Two reasons are there: small size, small atomic size, and high electronegativity. F2 is super halogen because highly reactive compared to other elements within the group, and also at F atomic size is very small and high electronegative value is very high. Now discuss about oxidation states. Oxidation. Discuss our 17th group elements: fluorine, chlorine, bromine, iodine, astatine. Now discuss oxidation states. First element is F, fluorine. F exhibit only -1 oxidation state. F exhibit only -1 oxidation state because absence of d orbitals. For example, F atomic number is 9, electron configuration 1s2, 2s2, 2p5. 2d is not present. 2d is not available. D is starting 3, third orbit. D is starting third orbit, not 2 second orbit. So F exhibit only -1 oxidation state because absence of d orbitals. Next one. Chlorine, bromine, iodine, astatine. Except chlorine, bromine, iodine exhibit variable oxidation states. Chlorine, bromine, iodine exhibit variable oxidation state because presence of d orbitals. Available in d orbitals. Now, chlorine, bromine, iodine exhibit -1 oxidation state, +1, +3, +5, +7 also. Both positive and negative is exhibited. Chlorine, bromine, iodine exhibited -1, +1, +3, +5, +7. Exhibited both positive and negative oxidation state. Explain how chlorine NS2NP5 in ground state configuration. General explanation in chlorine, bromine, and iodine. General explanation. Chlorine atomic number is 7. Chlorine NS2NP5, Nd is 0. In ground state, only one unpaired electron there. NS2NP5 means one unpaired electron there. Gain of 1 electron -1 oxidation state. Loss of electron +1. So exhibited in ground state +1 and -1. Only chlorine or bromine or iodine. Next, first excited state, 3 unpaired electrons are present. 3 unpaired electrons are present, exhibited +3. Exhibited +3 oxidation. First excited state. Ground state +1 or -1. First excited state +3. Second excited state, 5 unpaired electrons are there. Second excited state, 5 unpaired electrons there. Exhibited +5 oxidation state. Third excited state, 7 unpaired electrons are there. Exhibited +7 oxidation state. +7 oxidation state. So next one, oxides. Fluorine forms 2 oxides. Fluorine forms 2 oxides. OF2 and O2F2. OF2 and O2F2. It is also called oxygen fluorides. Oxygen fluorides. Because high electronegative of fluorine than oxygen. F is high electronegative atom, total periodic table. F is more 4.0. Oxygen is less compared to fluorine. Oxygen is less electronegative compared to fluorine. Now explain the name. OF2. OF2 name is oxygen difluoride. Oxygen difluoride is the correct name. Difluoride oxygen. Next, difluoride oxygen is not correct. Once again, oxygen difluoride name is correct. Difluoride oxygen is not correct because F electronegativity is more compared to oxygen. So the name is OF2 means oxygen difluoride. Very, very important. 2 marks questions. What is the name of OF2 and O2F2? So O2F2 also dioxygen difluoride. Dioxygen difluoride is correct. Difluoride dioxygen not correct. What is the reason? Above reason. F is a high electronegative compared to oxygen. Very, very important 2 marks question. Next, general, another oxides of chlorine. Chlorine, Cl2O. Chlorine monoxide. Cl2O. Chlorine monoxide. Next, ClO2. Chlorine dioxide. Chlorine dioxide. It is used in a bleaching agent. Bleaching agent. Very, very important. Which chlorine oxide used in bleaching agent? Chlorine dioxide. Chlorine dioxide. Formula is ClO2. What is the meaning of bleaching agent? Color to colorless. Color ఉన్నదాన్ని color లేకుండా చేయడం. Color to colorless. So next one, Cl2O6. Chlorine hexoxide. Third one, Cl2O6. Chlorine hexoxide. Fourth one, Cl2O7. Cl2O7. Chlorine heptoxide. Chlorine heptoxide. This is acidic nature. Cl2O7 is a most Cl2O7 is a most acidic nature. So very, very important. ClO2 is chlorine dioxide is a bleaching agent. Next one, bromine oxides are also there. Bromine oxides also there. Br2O, BrO2, BrO3. So this